Good afternoon, morning, evening to you all out there. Welcome to my talk. This is actually my first talk, so pretty excited about it. So my talk, as you can see, is a bunch of words: cloud, Kubernetes, infrastructure as code, DevOps, a lot of markety kind of words out there, but they all stand for something, right? So as I mentioned in our chat, talk is definitely beginner friendly, but will also hopefully provide something for the most experienced folks. So without further ado, over here, quick disclaimer. Obviously, everything that I'm talking about here is my opinions and my own views that do not reflect the United States government, Department of Defense, VetSec, or my employer in any way, shape, or form. So why you should listen to me, right? This is always whenever you instruct or anything like that, it's like, why should you listen? Why should you care? So first of all, I'm not marketing. I'm not marketing you anything. I'm not trying to sell you anything. I'm not trying to sell you a product. Join my community. We're already all part of a great community, which is VetSec. So that's reason number one. And hopefully, when you guys see who I am, hopefully you'll decide just to, pay attention, learn a little more, and understand kind of where I'm coming from. So first of all, family man, love my family. I'm a veteran, did 20 years in the United States Air Force before transitioning. Self-taught programmer, but eventually took some classes and learned more, all kinds of different programming languages. Currently, I work as a DevOps and platform engineer with Booz Allen. I've been a VetSec member for about 1.5 years, maybe a little bit more than that. Also, Level Effect graduate. That's where my, cybersecurity background, in addition to some of the other courses that I've taken. But I was very honored to be selected as one of the VetSec scholarship recipients. I do have 5 active certs right now. I got my Sec Plus. I got my CCNA to get some of that networking knowledge. All that when I initially, before I transitioned. Then I got my Solutions Architect Associate, my Certified Kubernetes Administrator, and then my HashiCorp Terraform Associate. And for my location-wise, I have a graduate degree. So my transition from the military, I literally just, my last day in the military was June 30th this year. So I literally just went through my transition. So I'm just going to touch on this really quick before we get into the whole technology side of things. First of all, I found out about VetSec, got interested in cybersecurity, started learning more, mingling with the community, and appreciate every single person that's out there that's always answering questions to all the members. It helped me out a lot and figure out kind of sort of where I wanted to go. So I was also fortunate to go through the SkillBridge program, and within the SkillBridge program, I decided to go with the Hiring Our Heroes program because it is the most, similar to actually being out there and having to have a resume and putting it out there. So a bunch of different companies looked at your resume. It simulates, as we say in the military, the real world, right? And I got really lucky that I got multiple offers and I was able to choose, and I chose my current company, and I went through an amazing program, an amazing cohort in that program, and my team that I went through. I was not by myself; it was 5 of us, working on the same project. I got really lucky. We all gelled together. We all worked together, and I had one more member that was my technical counterpart. And that was amazing in motivation, learning, just having somebody else to bounce ideas against. So I ended up being picked up by my company right now. So that was my successful transition. I've been employed with the company for about 6 months now. So what I hope that you're gonna get out of this talk is that we all, whether you are IT, a developer, or cybersecurity, or leadership position, we all have a responsibility to start moving security left of bang. What I mean left of bang, it's also called shift left. out there. Bang, it's like your deployment. From that point on, your infrastructure, your application, everything else is out there. It's handling real data. It has public IPs and ports that can be reached by anybody. The other thing that I hope that you can get out of this is that cloud, DevOps, DevSecOps, it's actually a really good career post-military. And in my opinion, it's a really good way of getting into cybersecurity and learning more about vulnerabilities and be able to like dip your toes in that way. So we're gonna cover 3 main sections out of my talk. One is like a foundation. We're gonna go talk about all the technical, requirements for kind of like working in cloud, what's available out there. Then we're gonna touch on security and the cloud and microservices, and then we'll talk about education. What is my recommended path that you should take if you want to get into cloud? So foundations. First of all, want to clear the air, some definitions over here. So besides everything that you can read on the internet, and then, DevOps, nobody knows what's doing DevOps, right? Because one company can call you a DevOps engineer, you can be doing one thing, and some other company have you doing something else, right? But the whole point behind DevOps or DevOps methodology is you integrate and automate X. X just stands for a variable for tools, any tool to kind of improve and shorten that software development lifecycle. DevSecOps, you're actually still doing the dev and the ops out of it. You're just adding security and automating security out of that. So that's my standpoint on that. Platform engineering, and I'm pretty sure you'll probably hearing that a lot more often. It's kind of like a variant of DevOps, but it focuses specifically on infrastructure. And kind of like it says here, like the web of tools. There's a lot of tools currently for managing and making your infrastructure very scalable, and it gets very complicated really quick. So it needs folks to be able to like focus on just that. Monolithic architecture, just like only one instance, front end, back end, with probably the database in there, and that gets copied to something else, right? Something goes wrong with that instance, that entire instance goes down. Microservices architecture, with the idea of breaking apart that entire monolithic architecture into multiple services that will do different parts of services within that infrastructure. CI/CD, and I actually separated a second CD in there. So continuous integration is that idea of kind of like automating that beginning of that development cycle. Continuous delivery is the first CD, which is be able to do the tests that you need to do, and then that either that image, that build for your application or whatever, it's ready then to be pushed into production. And continuous delivery is kind of like that last step. Obviously, delivery and delivery and deployment, both of them can be sort of interchangeably, but technically they're 2 different phases, right, of being able to send an application out into the wild. And then cloud, everybody's favorite joke, right? That cloud is pretty much somebody else's computer. Well, tell you what, that grandpa's computer from like the 90s, running Windows 3 with like 60 megabytes RAM, 1 gigabyte hard drive, it's probably not going to handle what you want to put in it right now. So what is cloud? Technically, to be considered a cloud, you have to meet kind of like this 5 requirements. And by the way, Simon, the AWS specifically, so I'm AWS centric in my approach to things, because that's what I know. So on-demand self-service, right? You should be able to pretty much start, stop any service, anything that you want. We just click the button. You shouldn't be calling anybody, talking to anybody. That broad network access, you should be able to access from anywhere. That's why cloud jobs are really awesome as a kind of like a work from home thing, because you pretty much can do it from anywhere, unless you're in a classified environment. But that's a different beast. Resource pooling, kind of like economies of scale, right? They should be able to be a little bit cheaper, right? But we all heard probably the horror stories of bills coming at you really high for different reasons, right? Rapid elasticity. Here comes with the part that they win at scaling, and why this like microservices technologies which is in addition to all the cloud stuff, why it thrives on this new like environment. And then measured services, right? You're gonna be paying like cents, and that accumulates per minute, per hour, per megabyte, gigabyte that you transfer. Each service is different, but it can get expensive quickly. Okay, so let's get into cloud technology. The top three right now: AWS, Azure, and Google Cloud Platform. As you can see, all of them have a lot of services and products internally. And whenever you study for the certification, you have to learn a lot of those services, and it's very that provider specific. But there are certain commonalities to what they do. And as a matter of fact, they just call like different names, but they're doing exactly the same thing, which is this computing. They're serverless, which AWS called Lambda. All it is, you're able to run literally code, and that code does things, but you don't have to manage the server. There's always a server behind. Storage, databases, you're able to do network. They all function with the idea of a private virtual cloud. So you are in your own little bubble, away from other people. And they also all have some kind of like resiliency, which is they have different availability zones or whatever or regions or whatever that provider calls it, right? But the cool thing with these three, the certifications, to learn about them. And with certifications come job opportunities. There are other cloud providers out there, and they're maybe a little bit less known, but they're still like good cloud providers, and be pretty good maybe for your personal projects, or if the employer that you're targeting use this clouds. I'm pretty sure you probably have less competition if you're like really good at it or have experience with these. All right, so the other part, one of the other, I guess, ingredients of becoming a DevOps engineer or cloud engineer is Linux. Linux is the OS of the cloud, unless you're in Azure, right? Then you have some of the Windows. For the most part, you're running some kind of Linux, right? And that doesn't change because the majority of the servers used to run some kind of Linux. Itself, like Amazon, their free AMI that you get, which is their OS image or ISO, is Linux based. All right, and the next part is learning about containers. And very important is that containers are not virtual machines. So you can see here, they're kind of similar, but the difference is there's no operating system being virtualized. So the containers do not virtualize and emulate a CPU RAM so that an OS can run on it. Pretty much the container system runs on a container runtime, or they call it container engine. And then literally each container runs one or more process. And once that process dies, that container dies, stops working. For the most part. So talking about containers, why containers are so important when you run like cloud, and specifically Kubernetes, because we're going to get into Kubernetes. It's not needed. You can do everything computing without having to ever touch Kubernetes or containers or anything like that. But if you're working for enterprise or you're targeting to work for an enterprise, you'll have to learn containers at some point. And honestly, they're very useful. And they're very useful also for setting up labs, so you can hack containers at home. So they're lightweight. Containers package with all the dependencies. And usually 3 parts that are very important for containers. One is a build. You do have to build an image, or you can build it from the ground up. That way you know everything that's inside of that container. You can also either use a registry, which is literally just where you store the image. Docker Hub is one of the most, probably the most famous one. Google also. In every cloud provider have like their own variant of a container registry. You can find Ubuntu, you can find all kinds of like official images in the registries, and you can use that either on your own projects or at home as well. And there's also the engine. The engine is the runtime that will run the container on top of that. And there are multiple engines, as you can see here. Docker, Podman, and not all of them are specifically engines. Some of them are for building images. But from all these, that last bullet at the bottom, Docker is definitely the most famous, I guess, or the most well-known. So Docker itself, when you start looking into Docker, you need it if you want to start messing around with containers. And it's probably the easiest way to get started as well. There's a Docker desktop, just an application that you can download in your desktop, and I highly recommend that because it's extremely useful, and you can do more things than just run container with Docker desktop. The Docker engine is separate from the desktop. The desktop includes it, but the engine is actually what runs containers, whether on the cloud or on your computer. They also have the Docker CLI, so you can communicate with all the containers. You can kind of like any other CLI, kind of like Linux. There's a lot of things that you can look into a container. And as a matter of fact, you can do the equivalent of SSH into a container to pull data from it, pull logs, do all kind of different things. The next idea is the Docker file. Docker file is what you use to create images, and in there, using like declarative, I guess, programming, you say what you want in there, and you use that to build your image. It's extremely useful, and it's used. What is that like? If you work in an enterprise, you probably find yourself a lot of times like building images as well. Docker Compose, it's, you can look at it kind of like a Kubernetes light to a certain extent, which is the fancy word is container orchestration, but it's pretty much how do you manage multiple containers that they all do different things in order to get one application like working, right? Not one application, but to get one effect what you want, whether that is like have a web application out there or your business. And Docker Swarm used to be kind of like the old like Kubernetes light, same idea. And now they switch it from Docker Swarm. There's still something that's called Swarm mode, but that's part of the Docker engine whenever you want to run like multiple container or a multi-container environment. All right, and getting into Kubernetes, I gotta be honest, like when I started, Kubernetes scared me a lot because I heard that word a lot and I had no idea what it was, what Kubernetes was, and just like if any of you all had worked with JavaScript, just like the JavaScript ecosystem is crazy, constantly changing, always new tools. You can get lost pretty quickly in there. It's kind of like the same idea with like Kubernetes and the whole microservices thing. And I had no idea what was what until I started my path going more and more about it. So what is Kubernetes? It's just a system for automating, deployment, the scaling, and the management, multiple containers, or kind of like microservices. So that's another fancy word for that. Just having multiple containers, they'll communicate with each other into this thing that's called a cluster. And that is the application that handles all the process and execute the application that you show to the public, your client, and all stuff. But why use Kubernetes? Resiliency, and honestly, like scalability is the other important thing with Kubernetes clusters. They scale really well, and if a pod dies or a cluster die or one of your nodes die, they'll come back up if you have it set up correctly. So a big part and important, and I mentioned there, node spots, is the control plane. Those are like 3 different parts of the cluster that the 3 different parts that makes the cluster work together. Control plane, that's kind of self-explanatory to a certain extent. It handles all the kind of like the brains and communication and some of the database. Nodes is, think about it like as in like computing power, and the pods, they live inside nodes, and they're like different applications. Okay, and then kubectl, just a kube control, however you want to pronounce it, is a CLI tool for controlling Kubernetes. All right, another very important idea for the cloud is the idea of infrastructure as code, and be able to control the creation and the destruction of your infrastructure with just code. Literally, Terraform is a good example of this. It's like 3 commands, and you literally can have like a full cloud, full setup with Kubernetes and everything that you want in there, by doing Terraform init, Terraform plan, and then Terraform apply. And then when you want to get rid of it, Terraform destroy. Which is one of the really cool things about cloud system, and not only cloud system, you can actually use that on your computer as well for starting and creating labs if you wanted to. Anyway, so the whole idea of infrastructure as code is ubiquitous, same thing amongst cloud providers. Each one of them have their own version of it. AWS has CloudFormation, Azure Resource Templates, and the Google Deployment Manager. But if you are either on a multi-cloud system, or you want to use what's currently the we call it the most used tool is Terraform. However, recently Terraform, they were open source. They changed their business license, and to that there was a schism within the open source community, and they created OpenTofu. And if you read OpenTofu out there, it's literally Terraform right now as a version 1.5.5. They're both equal for the most part. With time, they will drift from each other, but that's out there. Oh yeah, and Ansible Pain Train. No, thank you. Stay with Terraform. But it's another way of managing it. You know, you have Chef, Puppet, Ansible. There are multiple ways of doing infrastructure as code. And what's really cool with infrastructure as code, Kevin, I agree. Strengths and weaknesses to all of them. And actually, you can combine all of them. You don't have to choose just one. You can do more than just infrastructure. And we'll get into that a little bit later in the talk. Okay, the next concept is GitOps. Okay, and then here's where we're start chatting more into the whole idea of X as code. The idea of GitOps is being able to use some kind of version control, more than likely Git, to be able to define anything as code, so that you can track it. You can do multiple versions. You can do static analysis of it. It's the basis for continuous integration and delivery. And the best thing of that is probably one of the best ways that you can use to secure your cloud environment is with infrastructure as code or excess code, because you can do policies, you can do detections, you can set up You can set up honeypots. You can set up honey tokens. You can do all this stuff through code, which you know exactly what it's on your environment, and you can track it. And if you all, and I'll have some slides later that's gonna show some data from SNCC, from like I think it's the current state of cloud security from 2022. And it talks about infrastructure as code being probably the best tool that we have right now to defend our environments. Okay, so in addition to this, then if we talk about Kubernetes, talk about microservices, then we have to talk about Cloud Native Computing Foundation and the Linux Foundation. It's a foundation that actually took over Kubernetes, and the majority of the open source ecosystem comes from them. They do have they incubate projects and they graduate projects, and they provide funding, training. If you have never checked them out, please check them out. They're pretty awesome. And here's some of the tools, and they have a bunch that are part of like the Kubernetes ecosystem to help you do pretty much anything that you want or need with just open source tooling. Which is Argo CD, is continuous integration delivery. Actually, even with Argo, you probably don't even need Jenkins, which is a CI/CD tool. GitHub Actions, you can also do it without just with Argo CD. Helm is a package, the Kubernetes package manager is a really easy way to deploy tooling into your Kubernetes environment. Yeah, Prometheus monitoring, that usually goes along with Grafana, which provides like dashboards and all stuff for Prometheus, or create your own dashboards. You can create policy and enforce it inside of your cloud and clusters with Open Policy Agent. You also have Linker and Istio, other service mesh, so you can do so you can define your network and what can communicate with what, firewalling, tracking, tracing, all kinds of stuff. And if you all probably heard it at some point, Netflix. I'm pretty sure that the idea of chaos engineering came up from was probably was there before Netflix, but I think Netflix probably made it famous. The idea of chaos engineering, which is literally just be able to have a system that will like shut down something on your system, either in production or development or any of your environment, so you can see how your tool will react. And actually, their Chaos Mesh is one of the multiple tools that you can do and use as to do chaos engineering inside of Kubernetes. And if you talk about Kubernetes and this whole ecosystem, you have to talk about Golang. The majority, if not all of them, all of these tools are actually made with Go. So for better or for worse, obviously that with Go comes all the improvement that Go's have, speed, reliability, security, also vulnerabilities that Go may have. Any of these tools, that those vulnerabilities will probably apply to them as well. So now that we're talking about vulnerabilities, let's shift a little bit into security and why security within the cloud is extremely important, and not only cloud, microservices, and kind of what you can do about it. So pretty important. Just this past year, 2022, you can see that the cloud security incidents are many in vary, right? We all heard about some kind of breach of somebody leaving an S3 bucket open, and then what was it, like I think some personal data, I can't remember if it's like VA data or something like that, was out there and was stolen. Crypto mining, hey, if you want to pay a really high bill for your computing, yeah, let somebody else do crypto mining, on your EC2 instances. This also requires a kind of like a mind shift, right? So if somebody's attacking your environment, your cloud environment, they kind of searching for the vulnerabilities, scanning, your, what used to be called perimeter and all stuff. And they pick a target, and what's out there, that's what they're gonna go after. With tools as like showed, and you can find I guess like open buckets that are out there. So it's very important to learn to configure your environment. So also here, specifically to the cloud side of things, is some of the most issues that are seen and or create security problems, right? You can see here insecure use of data backups. Well, you back up your data into an S3 bucket, then you leave it open. There we go. That's low hanging fruit for somebody to go grab. This slide specifically for container security. Container comes with its own challenges if you use Kubernetes. And you can see here, we can missing Kubernetes admission control policy. There are a lot of things that if you leave either by default or you don't further log down, that again, you just leave in an avenue for attack. So OWASP top 10, almost everybody that's on cybersecurity has heard about him. Guess what? For the most part, if you are working in the cloud and you have a public-facing website, or even certain areas that may touch the public internet or the public networks, you're open to these. Just from that web standpoint. Kubernetes itself has its own OWASP top 10. And here, like, for example, like number 3, overly permissive role-based access. That is a big deal in the Kubernetes environment. Now we go into the container. Docker itself and containers, for the most part, bring its own threats into the space and open your application and your environment to any of these threats. And you can see here, I just put that OWASP top 10 -2 because section 8 is what I could get in here. But somebody could get into your container and somebody could escape from that container and then go into another container. Once they get into your environment, obviously just like, I guess any of that hack, they start enumerating your environment. Same thing can be done in a microservices environment. And another one here, like for the last one, and I just thought about that, integrity of images. Whenever you're using public images, like in your Docker file, you have to be very careful that you are using the official ones. If not, then you should be creating your own your own container images. That way you know exactly what's on that image. And if you wanted to, you could actually host it like in your own repository. You don't have to even do it through Docker Hub or any other registries. Okay, continuing for like threats and vulnerabilities in the cloud environment. Infrastructure as code misconfigurations could actually open you up for attack. But as you can see, Terraform itself, it's fairly secure. Currently only has like 4 vulnerabilities, right? And just because something has vulnerabilities doesn't mean that is bad. It's just know that, it depends whether it's exploitable or there's already like an exploit in the wild. Can it be linked with the different vulnerabilities to increase the threat level for your environment? Those are things that you have to look into whenever you decide to use a specific tool. Golang itself, you can see, it has 137 vulnerabilities, but what does that mean? It's highly dependent on what you're doing, what you're using it for, right? Which one of the tools. And you can see here, container images, kind of like supply chain attack. They could, poison your image, and then I used an image that opens an avenue of attack, a container image. Same thing with the infrastructure like OS images, right? Either create your own AMIs or use official AMIs. Kubernetes itself has 52 vulnerabilities, and that's as of this morning. Yeah, 100%, Brett. Severity, criticality. That's all that matters a lot. Just because you have vulnerabilities, you have to like raise your hands and be like, oh, we're insecure. It just straight off, right? That's what this is all about. So one, I'll make clear, I'm not a pen tester in any way, shape, or form. More on the build side. However, I do like to learn about all this and always learning. So what are the common ways that somebody can attack the cloud side or your cloud provider side of things, right? And then all starts with the authentications. Everything communicates through some kind of API. Leaving those APIs insecure or not using encryption, maybe in that communication, that could open you up for attack. Certificates, well, do you send your certificate with code? Is it in your repository? Maybe you deleted it, but you forgot to delete it from your commit. So somebody can go back into your history and find your certificate in there. And if you did not cycle that certificate, that's, that opens you up for attack. Azure, and by the way, Azure's not the only one with that, with Active Directory, right? You could use Active Directory as an authentication method into some of the clouds, depending on how you have it set up and all stuff. And then with that comes Active Directory attacks that they could do against your environment. We were talking about public IP buckets, and you should be able to, leave it open out there. That's a no-no. And I already mentioned your code repo. If you're using a public GitHub, GitLab, make it private. If you're working for a company, they should have their own enterprise, and that should be completely segregated from the public. And if not, then you need to make sure that you scan your commits, and we'll talk about a tool for that later, to make sure there are no secrets, certificates, or anything along those lines in your commit history, not just in your repo, but also in your commit history. And securing your AWS instance metadata. Every single EC2 instance that you have for AWS, and I'm pretty sure probably Azure and maybe Google and some of the other clouds may have something similar, or maybe not. I don't know, but specifically AWS, they have this metadata, which is this IP, and you can get all kinds of information from your EC2 instance just by going in. By the way, obviously you have to be inside of your virtual cloud environment. But if somebody able to get in, all they have to do is go in there. Actually, a lot of folks that do penetration testing, that's the first stop. If they're on an AWS environment, just see if that metadata has been secured. Okay, moving into Kubernetes. Some attacks against Kubernetes, credential theft, same thing. Once you get to Kubernetes environment, you can do kubectl get secrets. That's another one. And if you just only have base64 encoded, you can even decode it right there on the terminal. That's a bad day. And misconfigure access control as well. That's another big issue for Kubernetes itself. And this leads us into just some of the challenges. You can see with the cloud and the whole microservices thing, that just it opens you up for more and broader avenues of attack into your environment. And misconfigurations are probably the biggest liability in a cloud environment, because that opens you up for access from the outside. And the other thing is complexity. You can definitely run a website with just a single EC2 instance without having to touch microservices, right? But when you start handling 100,000 more, like millions of visitors, like maybe a daily basis, and then computing intensive processes, that's when you start looking into microservices and be able to expand, split, and scale as needed. And with that, then comes all the complexity of all these tools and learning all these tools and be able to know how to configure them, and whether they have the budget for, company has budget for training, to train their engineers, and new tools come up all the time. So that's part of the challenge, right? And obviously, ultimately, cybersecurity itself, security itself, it's humans against humans, it's human ingenuity against human ingenuity, and that's one of there's the most important thing that I got, out of Level Effect was definitely that. So as we fix things, somebody else is figuring out how to get around them, and that's the challenge here with cloud and microservices. Okay, so kind of dipping into the DevSecOps side of things. However, this is not new. They're just taking like a new spin on that, which is application security testing and dynamic security testing, and then be able to do this from an automated perspective versus having an engineer dedicated to do some kind of like QA and fuzzing this up application. You kind of do it in an automated fashion for your cloud environment. The whole thing with static, the idea is for it to be able to look into your code and scan for vulnerabilities. And the whole thing with dynamic, obviously, is being able to do it on a runtime environment, and then do some kind of inputs or checking things that will only be alive in it when an application is running, and see what's the output, see how it behaves. And there are plenty of tools out there that can be used for this. Excuse me. Okay, so let's talk about kind of like the attack, the vulnerability of things. Now, shifting our mentality, hey, let's secure this cloud. Let's think about the best way, or the best way. What can we do in order to limit the probabilities of us getting hacked, right? And the best way to do is obviously think about moving that security left of bang. Left of bang means all the way from the developer, that's developing the application, and whoever is creating the infrastructure, whether that's your cloud engineer, that's your platform engineer, or your DevOps engineer, using security and security tools from there all the way to your deployment and your production environment. And from then on, obviously, then all the folks kind of like take that right of bang security kind of things, right? So for here, and at this point, MFA is important. I know MFA is not perfect, and there are different levels of MFA, but MFA is better than not MFA. And for those folks, multi-factor authentication. Pretty sure everybody knows, but just want to clarify that. Don't trust your defaults blindly. The cloud providers have been getting better, been more secure by default, but there's still things that can be unsecure by default. So looking at benchmark standards is a really good way to figure out what's the best way to set up your environment. Defense in depth, 100%, multiple layers, because not one layer is going to catch. It's not a matter of if, it's a matter of when, and what is the best way that we can detect that we have been hacked. Lockdown authentication methods, that's super important. And then using infrastructure as code. So you can define your security from code. You know exactly what you're looking at. You know exactly what your infrastructure looks like, all the way, from not just computing, but your network. what's open, what's not open. The policies, what are you enforcing, what are you not enforcing? Okay. Sorry, I just got a notification here. That's one more session. All right. So specifically to the cloud, right? Your root account. You don't want to use your root account on a daily basis. You want to set up an administrator. You want to secure that root account. Very strong username and password. Set up MFA immediately, and then put it to the side. Set up an IAM administrator, and then use that administrator as your daily driver to do everything else. IAM, your identity and access management. You want to be as granular as possible, kind of like a need-only basis. And when needed, try to use roles specifically. S3, I don't know. I think it would probably be that horse that no public IP. And if you have to be able to communicate, then there are ways to set up your buckets as private, something inside of your like another or instance or a pod is able to communicate with that S3 bucket from inside of your private cloud, and then that is the only thing that has access to your public IP. That's one way to set it up. And then the CI's benchmarks. Having some kind of guidance is always better than no guidance at all. All right. Securing containers and infrastructure as code. Load down images to a version, and then try to use Alpine, the Alpine variation of the image. Almost every image out there, and at least on the Docker Hub, has some kind of Alpine version. And the Alpine, all it is a minimal version of a Linux OS, and it only has what's needed for that specific OS. Like even Ubuntu has an Alpine version, and if you need other tools, you're always able to add it afterwards. And then infrastructure as code, scan your code. So I'm trying to go a little bit fast because I realized I'm running out of time. Securing Kubernetes, RBAC all day. Try to set up role-based access control for your Kubernetes. Protect your control plane because that's where your etcd lives. And that's it. If somebody gets a hold of etcd, that's where your secrets are stored. That's your database. Oh, thank you, appreciate it, Matthew. That's seeing like 12 more minutes. I guess if we go a little bit long, it might be fine. Protect your etcd, TLS encryption. You can set a firewall around it. You can whitelist and blacklist processes to run or not run on your containers or in your environment. And that's very important, right? Logs, audit logs, have those logs, pull them somewhere, save them somewhere, because logs is one of those things that like are a pain until you need them. And when you need them, you hope you have them so you can actually track and see what actually happened. And I already mentioned this, restrict your metadata access. All right. So security tools for the cloud and the Kubernetes environment. They are a ton of tools out there. And every day I keep learning more and more about them. And the cool thing about these, a lot of them, they have different purposes, but all of them can be done in some kind of like automated way. One that I've used personally is Sneak, and I'm gonna show a couple of slides of a project that I use Sneak on, so you can see how Sneak, the free version of it, looks. SonarQube Treevee is done by Aqua Security. It's open source, by the way. The majority of these are open source tools which you can implement in your project or environment. Terraform Scan is actually part of Treevee now. It used to be a separate project, but it's still available out there. And if you want to scan your HCL files for Terraform, you can scan them with that. Same thing with TerraScan and Checkov. Checkov is Python based. but they actually give you a really good breakdown of all your vulnerabilities, where it's coming from, based on the CIS benchmarks and all stuff. That one's like really cool. I talked about earlier, how can you scan your commit history? And Git Secrets is it's done by Amazon, by AWS. Really good tool to scan your commit history and make sure that you have not committed any secrets on your current code, in your current branches, but also if you go back in history, so they're not there, and if they're there, so you can get rid of them. I think somebody earlier gave a talk about CubeHound, if I'm not wrong. That's a really cool tool. I guess it just came out from Datadog for like pen testing your Kubernetes environment, which is something like really cool. I haven't messed around with it yet, but it's on my to-do list. KubeShark is actually Wireshark already like set up so you can deploy it inside of Kubernetes and you can start like analyzing your traffic. That's another cool tool out there. Falco is an open source tool by Sysdig. You can do like some kind of like all kinds of different scanning. You can see here Linter. Oh, another one. If you're into like pen testing and you want to learn more about pen testing, like Kubernetes environment, KubeHunter as well. Open policy agent. That's a really good way to set up policy and enforce policy as code. By the way, all these tools can be also used as code. You set up declaratively and then you deploy into your environment. And also you can use some of the web applications like Pentest stuff like SAP and Burp Suite. So here's an example of what Snyk looks like and what kind of data they give you. They look at, for example, this is for the Docker images. Excuse me. The Docker images. You can see here like it has like different versions and it's tracking what vulnerabilities and the level and all stuff. Here you can see a breakdown of the project. So it looks directly into your Docker file, your npm, any of the packages or dependencies that you may have, analyzes your code and your YAML as well. And this all these are Snyk, and if I didn't mention that, it checks your Terraform code as well for possible misconfigurations that you may have and or vulnerabilities. And this is just how it looks. So it's really cool tool. And I like here that I give you like exploit maturity, right? And that's depending on what that's available. I'm pretty sure they're getting this data from a third party. But that's extremely important because just because it's critical doesn't mean that it's really bad for you. Now we're gonna go into the education part and my advice of somebody that wants to get into cloud. For cloud, I call it the cloud trifecta, or certification trifecta, more specifically for cloud. If you want to get in cloud, this is kind of where you want to put your head into, and then practice. To one, decide what platform you want to go for your cloud. I specifically advise AWS because that's my path. That's what I know. But it's actually still a lot of companies obviously use Azure. And the cool thing about Google Cloud Platform, probably because it's not as big as the other two. Same thing as with the cloud platforms. If you decide to go for that one, you probably have less competition, but at the same time, like probably less opportunities for job. So for solutions architect, one of the first things, don't go for the cloud practitioner. If you already did it, that's awesome. But if you actually want to be hands-on keyboard and be more like cloud engineer and actually more on the technical side of things, you want to go directly for your solutions architect. And the best way to do it is to go to control.io. He has probably the best course out there for developing your skills. And I advise that to be combined with Stefan Marik's his Udemy course for the AWS SSA, because that is the best test prep. he goes, he covers breadth, while control covers depth on a lot of things with a lot of projects. And then Tutorials Dojo, it's advisable as practice says. Some other tests are a little bit harder than what is actually on the test, and they're harder some because they get it deeper into the questions, and some because it's kind of like hard to understand what they're asking for. Take that for what it is. If you want to go to Azure, Cloudly is .io. He actually works in conjunction with Control.io, and the level of quality of the scores for Azure specifically is the same. So I highly advise that. And obviously Google runs their own training, which is probably the best. From there on, time to like dive deep and go in with the sharks, Kubernetes. And although the multiple ways, I mean, and you don't have to get certified. Yeah, thanks, Mason. Yeah, I agree. It's like amazing instructor. And even if you're ever iffy about networking, just go watch his YouTube videos on networking. They're amazing the way he explained things. Just going back to Kubernetes, CKA. If you want to be an administrator, that's the route to go. All the Kubernetes exams are hands-on. None of them are multiple choice. But there are trainings and there are ways to get there and build up your skills. And my advice for CKA or CKAT, which is the developer, application developer for Kubernetes. And once you get any of those two, if you want to go for your security, the CKS, Kubernetes security, you can go for that as well. But it's through Code Cloud. It's very hands-on. Their instruction is really awesome. You can get the courses on Udemy, but it's better to go to their website because you have access to the entire infrastructure that they have. And with that, whenever you buy your certification test, that comes with 2 free tests for Killer does SH, which is the practice test for CKA, CKD, or CKS. Then after that, learning, if you want to go certify, and this is certification, having the skills, it's equally or more important than having the certifications, right? But usually certifications open doors to get into jobs, and kind of they force you, specifically this one's which are very hands-on, to kind of learn things. But just go for the HashiCorp certified Terraform associate. And again, I advise Code Cloud to build up your skills for that. And last and definitely not least, when I heard this, I was towards the tail end of my HOH program, and I went immediately and did this. And this thing definitely challenged me, which is the Cloud Resume Challenge. I think it's Cloud Resume Challenge.dev. It's a really good way to build skills, and it's going to force you to do things that probably somebody has been working on AWS or doing cloud for many years, and I haven't done this, right? They don't know. It makes you set up DNS, be able to use, I did AWS specifically, but you set up your own website. You build your infrastructure. It all has to be done through code. You set up an S3 bucket securely for a static web page. You have to set up your TLS, all kinds of stuff, and it's like all through like Amazon. And the Cloud Resume Challenge website, they have actually all 3 main providers. Same challenge, which is really cool. All right, then after that, build your own lab. I know with AWS, you can have like a 1 free year, and they give you a free tier. So you as long as you stay within those tiers, like computing power and storage and all the stuff, everything that you do is free. So you have plenty of practice set that you can do. And again, my advice, go take Control scores, because he goes from 0 to 100, and it's like 80 hours of content. with projects and all that stuff. But it shows you how to like set it up securely from the get-go. So if you have never done it, like that's the best way to learn right from the get-go. Then to practice containers, right? Obviously, you can also do it in the cloud. And in addition to the cloud, you download Docker Desktop. Not only you can do like containers, create Docker images and all stuff, but they came up with I think it's called like container environment, or development environment, something like that. Literally just running like an environment with all the dependencies. If you want to have like different projects with different versions of Python or different versions of npm, you can do like multiple projects like that. And I don't know, it's not mentioned here maybe, but Vagrant is another. Oh yeah, they have it there. You can also use Vagrant to like set up your tool and all stuff. To practice Kubernetes, obviously you can go in the cloud, but you can also practice on your computer with Minikube and with Docker Desktop. That's another stop for Docker Desktop. It will have a cluster ready for you, so you can deploy whatever you want in that cluster and test things out, tools and all stuff. Infrastructure as code, obviously Terraform, OpenTofu, just they're the leads right now for that. Still learn how to do it with that cloud specific and then translate that into Terraform. And then I mentioned here Vagrant. You can do that, but for like a local build environment. But you can also still build your local cluster with Terraform or OpenTofu. And then security, hey, download those tools and use them, test them out. There's always new tools coming out. Okay, it's coming out to the end of my talk. First of all, I want to thanks the VetSec founders, VetSec leadership. Thanks, Tom, and all the leaders for giving me the opportunity. Thanks to the VetSec community for all the good conversations, advice, and all that. Also want to thanks Personal Level Effect because they gave me the chance and the opportunity when I got the scholarship, and I'm not sponsored by anything in any way, shape, or form, right? But I'm very appreciative of what they want to learn, and I believe that those guys are the real deal. And a lot of the cybersecurity knowledge that I have nowadays, they gave me that really good solid foundation. And then Hire Not Heroes. If you're military, so active duty, looking at transitioning, it's just my advice that you cannot lose with the Hire Not Heroes program as your skill bridge option. And with that, that's the end of my talk. If anybody has any questions, I'm more than likely, I would love to answer those questions. Oh, thank you very much. Sonny, say any specific for IT PMs? Oof. Honestly, I don't know, but I mean, for anything PM, you can't go wrong with the PMP. And I think specifically the Project Management Institute, they have some kind of variant or some kind of focus for IT or for project managers. Thank you. See, if you go on kind of like project manager to understand and be able to better communicate with your engineers, again, go for the super entry level certification for the cloud. You know, that at that point, you know, if you're PM, that definitely then advise cloud practitioner or the 104 for Azure, and I'm pretty sure Google will have like something specific along those lines. For Kubernetes and Terraform, my advice is just take the training. There might be, if you're not going to be doing it, it's probably not worth your time to go for the certification. the CKA itself. I mean, so CKAD it's a little bit easier, but that's more like developer centric. Don't get me wrong, really useful. But you can go through the training and then have that knowledge. Hopefully that kind of answer your questions. I don't know if there might be other certifications out there that I don't know about specifically for PMs. Going down the line, yeah, Mason. The order that I mentioned will be my recommended order: Cloud, Kubernetes, Terraform. That's why I put it that way specifically. You have to know your cloud environment, because honestly, you can do everything with just your cloud. You can do full DevOps with just like AWS products or just Azure products. But the reality is, I think the enterprise, you probably see Kubernetes in a lot of this open source environment out there, and it's worth learning it. So that's my advice. Also, to this, I do have, I was not able to finish today time, but I'm putting a PDF together with the resources that I have and that I recommended. And I don't know if maybe I can just drop it here, or I can just drop it on VetSec on our Slack. That's available for everybody. Okay, going down the line. Next question. Okay, and I apologize if I'm butchering your name, Salia. Hopefully I pronounced that right. So if you don't vulnerability management, you're kind of interested into like cloud security. I don't know if you want to go towards like the thank you, the cloud pen testing side of things. Yeah, Black Hills Information Security, they have some really great training on cloud security and pen testing as well. Like really good training. If you want to go more towards the DevSecOps kind of things, honestly, I just learned about this website, but I haven't taken a course from them. I have a course coming up just to see what's the quality. It's called Practical DevSecOps, and they have some certifications in there for like container security and all stuff. I haven't taken the courses, so I probably next month. I don't know, because I have a course beginning of next month. But that'll be my advice, kind of like for cloud security. And honestly, cloud is like still a little bit of a wild west out there. And I agree, you shouldn't have to start from scratch, right? But learning about cloud and what I gave that trifecta, that's the foundation. And with those three, it will open doors for anything that you want. And once you get CKA or CKAD, you can go for the Cloud Kubernetes Security, which is a really tough test. But I'm pretty sure if you have it, that's going to open doors 100%. Did that answer your question, or am I missing anything? VM as in like virtual machines, or sorry. Vulnerability. Thank you. Yeah, I saw VM. My mind just went immediately to virtual machines. Yeah. Focus on vulnerability management. Then if you want to go in the cloud, I mean, that's that's what a lot of the DevSecOps do. It's kind of like vulnerability, or you can go information assurance spots that they do a lot of vulnerability management when you go into those kind of roles. So I'll probably my best for that. T-Rex, how long will it take to obtain the trifecta? I think it took me about 6 months. And that's, through the HOH program and then when I was working too. So 6 months about, part-time. Here. Average number of hours per week. And Sully, I'll go back to your comment there. Average number of hours per week. I put in a lot of time. I put in a lot of time. And I think overall, I think I tracked AWS. For AWS specifically, I clocked more than 100 hours total. And I think I was putting on average about 15 to 20 hours of just studying and doing projects. I was pretty much doing like 8 hours Saturday and Sunday, in addition to everything that I was working on the week with the project. Because our project was to put together an AWS based pipeline, CI/CD pipeline. So that's for AWS. CKA took me about a month, and I will say that probably did maybe about 10 to 15 hours a week during that month. Was still working full time. And then Terraform, honestly, was probably the easiest one because I already like messed around as I was doing my projects and studying and all stuff. Messed around with Terraform, and Terraform is multiple choice. So that one was like, just being familiar with it was half the battle. Okay, so they're going to compliance. Maybe compliance. GRC. Oh my goodness, what's this guy's name? Simple Cyber. Just look up Simple Cyber. There's like a GRC course that it's really good. You're welcome. T-Rex. That's really good if you're looking at that line of duty. And I'm pretty sure like there are plenty of others that have certifications and all stuff. Yep, and that's that cloud compliance. It's same thing. I think that's maybe so fresh. Again, I don't know because I don't work on compliance, but I'm pretty sure the GRC realm probably has like a lot of like cloud compliance stuff. So my advice, when in doubt, Google it out. I'm pretty sure that there's plenty of stuff. And then obviously SANS, but they're expensive, right? But I mean, probably good. But yeah, that's just look at check those folks out. Plus, I don't have like a specific example or direction that I can give you specifically for cloud compliance. But I'm pretty sure if it's still a little bit of Wild West, you don't find anything, you can't go wrong with just mixing those two parts, right? Learn cloud, and then learn GRC as well. Look into the benchmarks, the CIS, Center for Internet Security. They publish all the benchmarks, and they have AWS benchmarks. They have Azure benchmarks, like all kind of like cloud stuff. And that's a really good way of becoming like a SME on that specifically. And then I don't know, might still be pretty fresh out there. So, thanks, Matt. Yeah, the workbench. Yeah, nice. And by the way, a lot of this tools, DevSecOps tools that I mentioned, open source, a lot of them integrate the CIS benchmarks into them. So it's something like it's misconfigure or something like that, and they will tell you which benchmark like you're missing or you're not compliant with. That's one. There's also, is it CSA? Sorry, apologies if I'm mispronouncing that. But it's like a cloud security agency or something like that. That's another one that's like cloud specific. Yeah, Cloud Security Alliance. Thank you very much. That's another one that's out there, and I think they do have some certifications. But then again, I cannot speak on that because I haven't taken them myself. And that's really important. No matter what you look at out there in the internet and even in our own community, if somebody has not done like a certification or something like that, always take their advice with a grain of salt, right? Because we all can talk about like hearsay, but first-hand knowledge is probably the most important thing. That's a like what's the Tyler, the pug, always talking about like, hey, based on his experience and take his advice, along with many other folks as well on the community, right? If you've done it, if you've gone through it, that's probably better. I'll always look for people that have done it and ask for their advice. Anyways, any other questions? If not, then I'll be punching out. Oh, thank you all. I really appreciate all the good questions. Appreciate everybody's attention. Hopefully, you got something out of the talk. And then reach out to me. Literally, like it's my first name on the forum. So reach out, say hi. Okay. Well, thank you all for being here. Thanks, Matthew, Sonny, Celia, and everybody else that's here. Hope you all have a great day, great weekend, and keep enjoying the conference. Bye.